Let's imagine we have a hiker who travels some amount along the x-axis. Then she travels some amount along the y-axis. And then she goes along the x-axis. And she has a final displacement on the y-axis. How do we handle this scenario? Well, we've learned that vectors can be added in any order. Right now, we're taking delta x1, adding delta y1 tip to tail, and then adding delta x2 and delta y2. That's a logical order to use because it's the order in which she actually underwent each displacement. But it's more convenient mathematically to move these around. Let's connect all of the delta x's to each other first, and then connect all of the delta y's. This is nice because it makes a right triangle. And the total resultant displacement would be the hypotenuse. So how do we approach problems where there are multiple different displacements? We will be finding the total delta x, which is just the sum of the individual x displacements, the blue plus purple, and we'll find the total delta y. By adding the delta x's together, we are in effect connecting them tip to tail and forming the bottom of this right triangle. By adding the delta y's, we are essentially forming the other side of this right triangle. And why do we care about right triangles? Well, if you draw your delta x total and your delta y total, it doesn't look like an x. Then now you can draw in the resultant tail to tail and tip to tip. And it's really easy to find these unknown quantities because we could use hypotenuse squared equals opposite squared plus adjacent. Now the equations can be applied. There's another equation we get on our equation sheet. Theta is inverse tan of opposite over adjacent. So when we draw this and calculate in such a way as to form a right triangle, now we have access to these equations, which can help us find the unknown quantities. Okay, let's see an example. A hiker travels 6 meters east. East means positive, and that's a delta x or y. East is on the x-axis. That's the first way that she moves along the x-axis. Then she travels 4 meters north, that's up, so that's positive, and that's on the y-axis. She has a second displacement along the east direction, so that's another x displacement. And then she travels 5 meters north, that's the y-axis. North is positive, east is positive. Okay, all of these are positive. Calculate the magnitude of her resultant displacement and the direction of her resultant displacement. The magnitude of her resultant displacement is just delta r total. The direction of the displacement is the angle theta. Okay. So we have two things to find. But before we try and draw a picture, let's get the totals. You find the totals by adding up the individual displacements. So what do we have on the x-axis? We have 6 meters east. And then she went 7 meters east. Let's get rid of this. On the y-axis, she traveled 4 meters north, then 5 meters north. When we add, we get 13 meters east, because it's positive. And on the y-axis, she walked in total 9 meters north. We can draw this out easily, and we don't have to worry about, like, you know, if it's a really complicated problem where she goes north and then east and then west and then south and then north again and then west and then east and south and then north and then really far east and then south. This gets complicated, right? You can't just draw a picture. It's not reliable for that type of a complex problem. That's why this is such a great method. When it comes time to draw, we don't have to worry about all those individual things. We draw a single right triangle with delta x total. That's east, 13 meters, and delta y total. Wow, that's easy. 9 meters north. Then we can draw the resultant displacement and the angle. And we can easily find this. This is the magnitude of the displacement. Theta gives us the direction. We find the magnitude using hypotenuse squared equals adjacent squared plus opposite squared, and you solve. And you find the direction, theta, using inverse tan of opposite, that's the 9, over adjacent, the 13. And then you make sure you add, find the value, and the direction, theta, also has to include like that north of east thing. So that's how you solve these problems.